Welcome again to the last session for the day. Last but not least, we have Sina from Leaseweb who will talk about their CloudStack integration and how to expose router VM statistics to the customers. Welcome to the conference, Sina. How are you doing today?
Thanks, Ivat. I'm doing great. Glad to be here. Today I will show you how we manage.
So the stage.
Sorry. Okay. Today I'm going to show you the idea we have for the CloudStack to expose the VM statistic to the customers. Before that, let's just quickly talk about me. I'm Sina. I joined Leaseweb right before the Corona. I love programming in Java. Love computer networks, so the CloudStack is the good combination for me. I have a lot of hobbies, when I'm not programming or writing code, just cooking, building models, or hanging out. And that's basically me. So let's get to our Leaseweb. Quickly introduce Leaseweb. We are globally infrastructure as a service company. We have platform and data centers in Europe, Asia, North America, and we offer VPS to customers and resource pool with access to CloudStack dashboard. And we have also used CloudStack for our tools and our internal application and services. So let's talk about our talk. What we are going to achieve in this feature? We get a lot of tickets from customers that they say, "Oh, our network has an issue, but they don't know what's went wrong. We just checked for them. They have ping, they have access, they have anything, or router VM works correctly, or the things like these." Because the customer has zero knowledge about the network. We just give them network, they set up some abstracted things, and they don't know if it's doing great or not. With this feature, we try to reduce the cost of maintaining this environment, because if the customer knows that, they can simply restart the network with cleanup or changing the firewall rules or etc. And they can get it work. They don't have to raise a ticket. And another thing that also we want to achieve is to make it visible for customers, because they may get this information from the router VM, and they know that some of their VM they don't do as expected. They have a high network, or they get a lot of packets, or some malicious activities in their specific VM. So let's clear it a little bit more. We have explicit goals that we want to achieve. We want to make network visible for the customers, so they have idea of what's inside the VM. And we want it to be easy to use, so we don't have to put a lot of effort to train our support team, to train our customers to use that feature. This should be easily manageable from customer side. And it would be nice if it be integrated into the customers monitoring system, if it's possible. And with all of this, we want to reduce the support cost, because it's sometimes a lot of effort for us just to detect what's been wrong, and as customers, and this flow took a lot of time. And some implicit goals we have. It's a security. We don't want to expose the virtual router data to the internet, because we can easily do that, and the corrupt provide some security issue. And we want it to be, as I mentioned earlier, easy to implement and manage, because we don't want to spend a lot of time to create what is already there. It's hard to talk about monitoring and not mentioning Prometheus and Grafana. As you may have already known, Prometheus is time series database. It's scraped data from different sources, and Grafana is a tool to represent that data. It has a lot of dashboard. We can have a different data source. So our idea was to somehow use these tools and provide this feature to the customer. We don't. Another criteria for us was that we don't want to manage the Grafana and Prometheus, because the version and the template, a lot of support and maintenance costs will be applied to us. And we came to conclusion that it's good to just expose the data to the customer and let them decide what they want to do with those data. And let's see how we achieve that. Consider an isolated network. The router VM has one public interface and another internal interface. For simplicity, I assume that its IP is 10.0.0.1. And we will expose the data through this interface, because we don't want, as I mentioned earlier, we don't want to expose the data to the internet. Then customer create a VM in that network and install Prometheus there, or use the one that they already have, and scrap the data from the router VM. And they can also use the Grafana and in the same network, and then get the Prometheus data and show it really nice. And these two IPs are using them for the demo. It's not nothing to worry about. It's just so I can easily SSH to this VM and get the data. So, longest story short, let's see how we did that in a router VM. We installed default node exporter, Prometheus node exporter on router VM. We can later add feature or extend it. Then we run it on a specific port and IP in internal interface of the router VM. Later, we will let our customers choose if they want to run it on internal interface or external interface, because they may have they may want that to be exposed in external interface, but with some IP and firewall rules. And another thing we have to do is to add these two IP table rules so that that port is accessible from the internal network. I will show that in a demo later. So what do they do should do from the Prometheus part? If they have already the Prometheus installed, that just one line of actually 3 lines of codes in a configuration file. they add these trees, and the Prometheus automatically scrap those data and store it for later use. So that's just it. Nothing should be changed. And from Grafana, we introduce the Prometheus as a data source and create a dashboard for it, or we can use a default dashboard. So let's quickly see a demo. But before that, let's review it. I get back to this one when I'm talking about showing the demo. Here we have a CloudStack environment. By the way, we have to improve it. It took a lot of time. As you can see, we have a network. As a root admin, I can just go into this tab and see router VM and see if it's working. It has a lot of health check. But as a customer, we have zero access to that VM or health check data because we don't want to expose it, or we don't want to let customer manage those data. But somehow it's good to expose some data to the customer, because as I mentioned earlier, we get a ticket that said, guys, it's we have an issue here. We can access some random network, and we check that and see that the health check for the gateway failed, and it's easily fixed with restart. The customer can do that, but raise a ticket, and we have to say that it should be fixed in that way. So let's see. As a customer, I just see a router VM name, IP address, version, and if I click on that, it get the for error, because customer are not allowed to see this information. But with this feature, as I mentioned earlier, you see, here I run node exporter on internal network of the isolated network and in a specific port. Let's get back to this image. As you can see, I run this exporter at this interface, so it's safe. Nobody can access it except these two VM in an internal network. So what can customer do? They can make it bigger. This is the Prometheus host. We have it SSH to this IP, so I can show you that. If I run care in that IPM port, I can get this data. So as the Prometheus, how should I configure Prometheus to access those data? It's just one line here. These 3 lines of code. Customer can define it here, or the the Prometheus scrap those data to its database. And as you can see here, I have already run this query and get this information for router VM. Later, customer can configure the Grafana, and this is my dashboard for the Grafana. It's a default Prometheus dashboard. It has everything from the CPU usage to network usage, network traffic usage. So basically, I completed everything from these two sides, and now it's good to go. One thing I forgot to mention was the firewall rules. Customer, we have to add this firewall rule so that the only internal network has access to that port, a specific port, and a specific IP. And basically, that's it. I was too fast, I think. And we have a knife. I'm not sure what should I do now. I bet my presentation ends pretty soon.
If that was all, we can go to the Q&A, maybe?
Yeah, perfect.
Okay, let me see what questions we have so far. We have one question from Grigor, who is asking, when you say internal network, do you mean a CloudStack management network or the isolated network where VMs are attached?
Well, that's a good question. I created isolated network. The demo network was isolated network, and it has two interfaces. One for public access and one with public IP, and another one for internal network. And it's isolated network, not the management network or a storage network or anything inside the CloudStack, and customer can access.
Going to the next question, isn't exposing all the node export metrics to the customer?
See if it works, or it is worse to try to expose this data to the customer. I see that a lot of we can do a lot of configuration. My goal is to have like a tab here where you can configure in which IP you want to expose those data, in which port, and with which metrics.
I think we don't have any other questions now. So yeah, thank you, Sina, for joining us for the conference. I hope you will be able also to join our next events. As Giles mentioned, we are very excited to have the CloudStack Collaboration Conference at the end of the year as a hybrid event. So we hope we will meet you all in person.
That would be nice. Yeah. I hope to see you there.
And I use the chance to invite everybody to the last session for the day, because it's not going to be a session. It's just a quick networking. So take a drink, take a beer, or make some kind of cocktail, and we will wait you in the next talk. Thank you, everybody, for being with us throughout the whole day.